an academic of Geology, Mohanlal Sukhadia University, Udaipur, Rajasthan. He has been awarded with the prestigious fellowship from the INSA and Humboldt Research Fellowship. He is also a recipient of National Mineral Award by Government of India. He has authored 3 books: Fundamental of Geology, Geology of Rajasthan, and Geology of India. Post retirement, he joined the Presidency Kolkata as a professor. And the topic of this lecture is Precambrian geology of Aravalli Mountains and adjacent area. Please, sir, I welcome you.
Hello. Hope you can hear. Okay, thank you. Yeah, okay. Pointer. If I show it here, it will cover. How to begin? Okay. How to begin? Okay. I wanted to talk about closer to the title of what is given. The seminar. Truly speaking, Proterozoic and Archaean. These two are included in one term, Precambrian. Is it okay? Precambrian means whatever happened before Cambrian. That is, one is Proterozoic and other is Archaean. I will be talking about the mountain, which is very important in Rajasthan. The mountain is Aravalli Mountain range. That's why I kept the title closer to that. Okay. And adjacent areas, yes, some regions which I have included are not part of it. So adjacent areas are to be taken. For example, Sirohi. Sirohi is on the western side, southwestern side of Aravalli Mountain. It's not truly, doesn't make the Aravalli Mountain. Sirohi there are some other things also which are not the western Rajasthan, but far away from that. Malanis and many other features are there. The map, as you can see, Aravalli Mountains and adjacent areas is number 6 in the slide. Number 6 is the western part, which include also the Aravalli Mountains. Sorry. A geological foundation, the main geological work, and who built it of this ancient terrain initially by several geologists, including Coulson, the earliest one, Gupta and Mukherjee. P.N. Mukherjee, she was a paleontologist. But he joined Geological Survey of India, and there they don't keep these divisions. Hackett. All they have done wonderful works. Hackett in 1881, perhaps the first geologist, earliest geologist to take up this subject. Then the work of Heron, A.M. Heron, wonderful. He worked in 1917, then 23 to 32, 35, 36, 19, all are 1953. Latouche is also from Geological Survey of India. And all of them prepared geological stratigraphy and map. The present map published by the Geological Survey of India is not mentioned in my work because they recognize 101 formations, which is absurd. Actually, the oldest section of Heron and Associates is like this. Archaean included the Aravalli system, also included in the Aravalli at that time. Banded Gneissic complex and Bundelkhand. Then comes the post-Aravalli pre-Delhi granitoids. I'm talking about the Heron succession. Erinpura Archaean interval, that is the time between Archaean and Proterozoic, includes Delhi system. This is old terminology. Then Erinpura granite. Jalore and Sivana granite. Yes, I was talking about Sivana. There is someone from Sivana. Where is that? Oh, Ritesh, sorry, K.K. Sharma. Really. Malani lights. Present excavation, it is not only restricted to Aravalli Mountain or Rajasthan, it extends well into the Himalayas, now in Himalayas, and Indian system. There are several significant features. Identification of Archaean basement consisting of the banded gneissic complex and Bundelkhand ice. Recognition of younger Archaean rocks. Meta-sedimentary succession, cover succession, and described as Aravalli system. It was also included in the Archaean system. Then this is important. Erosion and conformity. Many of us write about the erosional ice. It's not true. Correct. Its true name is erosional conformity between the cover Aravalli system and the basement example. And then Rayalo was included into the system. And Rayalo deposits taking place during the Archean interval, the time between the Archean and younger rocks. So, subsequent to the Heron's monumental work, number of succession relating to age, correlation, spatial distribution of the lithotectonic units. Opinions are obviously diverse. And the present discussion that I will be presenting here, primarily based on two books published by me with my co-authors. One was by myself and Zakhar, the Geology of Rajasthan, Precambrian to recent. This book is very widely published and printed in different parts of the world. Some inputs were added subsequent to the publication of volume by me and Ritesh, my dear student. Where is that? Is here? Okay. Yes. We begin our discussion from Udaipur Valley, surrounding regions which expose the most instructive evidence of providing clues helping stratigraphic revision of the Precambrian rocks. Yes, you won't find this anywhere in the world. Certain recognized granitized bodies around Udaipur as intrusive bodies into the Aravalli system, marked as X1, X2, X3, X4. You can perhaps see in the map. And recent studies clearly indicate the presence of Archaean basement in Rajasthan and status of these granitized bodies. Basement rocks include gneisses of different types. I have shown these in the photographs. Most of these picture was taken from north of Nathdwara, further north of Nathdwara. And I have to acknowledge this Azimuddin Shiwani from Aligarh Muslim University. He had given me this picture. Apart from direct evidence of age of the basement, indirect proof of old age by determination of ages, 3,230 million years. MA is abbreviation of million years old. Lead age of digital zircon. I couldn't give the authors, several authors were done by me, with me. One of them was Alfred Kroner of Bochum University. Well, the most significant feature which struck me is the minerals at the base of a hillock, which has been named, when it was named and mined and sold as pyrophyllite. It's not true. It's aluminous silicate, not pyrophyllite. And this was proved to be soils. Paleosoil means the soils present in the past, at that time. Well preserved is only in Udaipur and some areas in the year. It is a wonderful situation, providing static, lithological characteristics of what is the basement, the cover rocks, which are now we subsequently named as Aravalli supergroup. But apart from paleosol means past soil preserved in rocks. The other geological features which confirm the basement status of the granitized bodies marked as X1, X2, X3, and X4 in the map here. You can see it. Earlier, these were proved to be basement, which were earlier described as intrusive rocks. Then I was invited by the Rajasthan State Mines and Geology. When this phosphorite deposit was discovered, to map the area. I can't name, I should have added and I tried to find out. I couldn't get it. Who were associated with me in mapping this wonderful map of Chamarkotra, where you can see the fossil bearing, stromatolite bearing rocks, limestone, dolomitic limestone, and also the gneisses. Oh, sorry. Okay. Is it okay? And another younger section of the Aravalli rocks is the Greywack overlying the phyllite. And there are certain places we get this relationship. One is the top one. I had several visitors, geological visitors. Two of them are here, and they came from the California State University, UCLA, Los Angeles. The top one. I can have which one? This one. I could. But if I want to show that arrow, oh, it's not possible. Okay. Okay. Leave it. I'll be kind of I'll do this way. Yeah, one succession rift. What? Yeah, I should show this. Which one? Oh, pointer. This is pointer. Oh, so because it is going up. Oh, yeah. Oh. Where? ठीक है. I hope you don't have any difficulty in finding. The top left is the Greywack Dolomite relationship, somewhere on the way to Jamarkotra. Then the next one is Greywack system, Greywack Pillage system. The whitish bands are the Sandoz band, sandalite. And then the dark one is the phylitic band. And the graded bedded Greywack is seen. I also saw these days. Presently, is not preserved in while going to Jamarkotra. And the last one, that is the history of this one. It's a boulder beds. This is a glacial deposit. This is typical. You have boulders, you have pebbles, etc., all mixed together. This succession you can get only in the glacial bed. The boulders are carried from big boulders. All these outcrops you destroyed cannot be seen. And someone in Udaipur, he made a wall to stop people going and seeing this rock. He was wondering what I am doing with students, but I used to go to see this. This such wonderful picture is not more available. Younger to that, much younger, is the lead zinc deposits, which you get. One is our area, and little south of it there are few, and also in the Rampura Agucha mines area and surrounding areas. The huge thickness of this mountain. I cannot use two together. Dark band, you can see a thick band of lead zinc mainly. But here some iron ores are also present. over. After, I think. Can you help me? Next slide. Okay. Well, I'm taking too much of time. Sorry for that. This is a stratigraphic column of the Aravalli supergroup. The oldest one, oldest bit, it is lying over the Archaean, so it's an unconformity above that. The first is the lower Aravalli group. Second is the middle Aravalli group. And third one is the younger groups. The first you have the Archaean, APB means Archaean Proterozoic boundary. It's wonderful things that we have in Rajasthan. It included namely two formations. Here we, what is that? Delaware formations. You may have to, I don't know, field work is not known there. Otherwise, you could see these things. Volcanic rocks associated with the meta sediments. I mean, yeah, a few meta sedimentary bodies are there. Stromatolitic rock over there. Was the Yama sequence. The Delaware is dominantly a volcanic sediments. The next one is stromatolite ridge. You can see the middle one and lower one. Did I say lower or earlier one? Lower one is the pyrophyllite, means previously sold, commercially known as pyrophyllite. It is mica-rich rock, not pyrophyllite, truly. Sedicite is better term, maybe. Oh. No well-constrained radiometric dates are known from Aravalli supergroup, truly speaking. It could not be geochronologically dated properly. Some information are there. Hints, it is only the hint about the Aravalli Basin opening, comes from the late model age 2075 and 2150 million years in the Aravalli basal volcanoes. And reference is there. There is a process called neodymium model age around 2200. The basal Aravalli volcanics were dated by Ahmed from Aligarh Muslim University with some co-authors. I forgot the name. And the basin closing, when the Aravalli rocks closed, no deposition took place after that, is the time 1850 million years. 185 करोड़ साल पहले 150 से 185 तक 50 1900 मिलियन ईयर्स इस टाइम के बीच में और डेटिंग जो किए हुए थे गोपालन PRL and A.K. Chaudhary, his research student. Then later is Dolomite by Sarangi of Utkal University. Someone is here, I think. Sarangi, 206. And zinc ages, mostly with Kroner. I am the author. Roy et al. I don't remember the authors, name of the all authors. Next is the Delhi system of rocks, properly called, we now call it Delhi Fold Belt, forms the backbone of the Aravalli Mountains. No, no, no. Can I show? The brownish yellow is the zone of the Aravalli, Delhi system of rocks, dominantly. And also, here this side, pink, light pink, and then on the western side, I will come to that later. Alluvar Bayana Basin is the main basin rock. Main Delhi belt. They are the deep yellow color of material. And the third one is the Lal Sot Reef Basin. Is that one? At the north of Chittorgarh. Next. Sorry. This is the type of the fold patterns that we find in the Delhi. Delhi have the three fold systems. One is isoclinal, other is open. This one. But you see, I think you can see. And the V-shaped body with open folds, upright folds. Upright means the axial plane is vertical. Delhi Basin is subdivided into the northern older fold belt and southern fold belt. We can't do anything more than that. No definite boundary is found between this north and south to define the boundary recognizable between the north and south belts. Okay. A three-tier classification has been recognized in the Alawar Bayana Basin. Rayalo at the base, Alawar above that, and then Hazargarh group. The stratigraphic scheme cannot be applied to the entire Delhi fold belt. It's not possible. No work has been done on much on that. In fact, there is no acceptable stratigraphic succession for the entire Delhi fold belt. Delhi Basin. Delhi Basin, which opened in isolated extensional rift, show a common pattern of polyphase folding and metamorphism. Basins later co-joined during the orogenic closing at 1450 million years. Basin, especially the southern part of the main Delhi Basin, underwent repeated thermal cycles, means repeated temperature rise and metamorphism or something else, or magmatic volcanic eruptions. The three dates are available, well dated. One is 1,000 million years, other is 850 million years, and 750 million years. Using different isotopic constraints, 1,000 million years age reported from different parts of the Aravalli Mountains. The age reflects thermal reconstitution of the pre-existing crust in almost along the entire Delhi fold belt. This was also the time when a transitory basin formed west of main basin for the deposition of the younger Shirohi rocks. This is the southern basin. So you can see the Shirohi basin. I think this was mapped by Ritesh. Ritesh, you did it. I with co-authors. Oh, K.K. Sharma. Thank you. In absence of any direct contact, Delhi and Aravalli Basin, relative stratigraphic relationship of Sirhi Basin with respect to the others is indicated by a relatively simple deformation pattern of metamorphic history of the Sirhi rocks. Single zircon is available, age is available of the Sirhi Basin, indicating 920 million years age of the granite basement of the Sirhi Basin. 835 plus minus 15 million years age computed from isotope dates. We start to mark the close of the Aravalli Basin, Sirhi Basin. This was the time of extensive granitic intrusions around Sirhi and adjacent areas. Well, there are a few other Precambrian rocks over there. The Malani group, an important Malani group. Malani group includes sediments in some linear basins, and entire ensemble is constituted bimodal volcanic rocks. At the top, you can see. Minor mafic bodies, intrusion of granites evolving different depths, and different basement at what from Earth's crust and which depth they have come up. And then Aravalli mountain base is flanked by the two stable cartonic basins. Cartonic basin means where sediments have not been deformed or metamorphosed. One is Vindian group on the eastern side, blue colored, and the Maravar supergroup, the gray colored rocks on the western side. That means the entire mountain rocks were already formed over there. After that, when there was no deformation, these two bodies deposited volcanic. Of course, Indian supergroup rocks at the boundary, western boundary, show some deformation. That is because when the Aravalli mountain range had formed a much later stage, geologically much younger, much later stage. Here are the Maravar supergroup rocks. Show the details, which starts with Pokhran boulder beds. I think most of you know about the Pokhran, where atomic blast was tested first. And if you go there, you can see some boulder rocks with huge bodies. This is an indication of glacial deposition. I mean, because of absence of any Paleozoic shelly fossils, there was no Paleozoic shelly fossil was found. It is presumed that the basin had dated 545 million years, with the end of Precambrian. And strontium sulfur isotope studies of carbonate and reported suggest late Neoproterozoic to Cambrian age of the Maravar supergroup. Finally, we have this succession that is revised and reconstructed by me and my students, many of students, some of them are here. Our Archaean basement includes the banded ICEAP. I retained the name, original name, but not in terms of age. Archaean basement includes Bandit-Gneissic complex and Bundelkhand gneiss and Nagranites. Age determined me with Kronar and some other, Bulbath and Male, some other were associated with me who had come. Archaean basement is 2,500 to 303,000 million years. And the orogenic belts are three Aravalli supergroup. I have used the term supergroup considering the present day description divided of the formation of rocks. Aravalli supergroup, Delhi supergroup, and Sirohi group. Sirohi group is a smaller time scale. And above that, Malani and Marwar supergroup. Thank you very much. I have finished. I might have taken. Thank you.
Thank you so much, sir. I would now like to invite Dr. Anjali Singh Ma'am, convener ICEAP 2024, to felicitate Professor Joseph G. Mate, sir, with Uparna, Mewari Park, bouquet, and memento. Sir, please. Professor Joseph G. Mate is a professor at University of Florida, USA. He has done his PhD He has done his PhD in geological sciences from University of Michigan and Arbor, 1993. His research interest areas are paleomagnetism and geochronology of Mesoproterozoic to earliest Paleozoic plate configuration, paleoclimate, and evolution of life on Earth. The topic of Sir's lecture is Quarter Century of Indian Precambrian Paleomagnetism, the Assembly of Peninsular India and its role in Proterozoic supercontinents. Sir, please.
Good morning, good afternoon, I guess it is right now. I want to thank Professor Purohit for organizing this conference and for the invitation. I know it's a tough thing to do, to organize this. And especially I want to thank all the helpers, the research associates, the students who do a lot of the work here. It's really appreciated by everyone, so thank you. And if I can indulge you for just a minute, I am here on a Fulbright Fellow to India, and part of the Fulbright mission is to be a scientific and diplomat from the U.S. to India, and there is also an India to U.S. And so I just want to mention a couple of things. And the first is really I'd like to give a message to the young scientists and the students in the group. And I think it's really important to give this message. And the message is simple. When I first came to University of Rajasthan, I gave a short course, and they gave me a replica of Gandhi's spinning wheel. And that spinning wheel has a very important message when India was trying to free itself from British rule. And by the way, my country also had to free itself from British rule, but we threw tea into the ocean instead. And the spinning wheel was, Gandhi encouraged Indians to make their own cloth and to free themselves from British production. And students, you should learn, you should respect your elders, you should learn from them, but you should spin your own research cloth. So don't be afraid to argue with your advisors politely. Dr. Pandit, who's a good friend of mine, was telling me before this, Dr. Roy was his advisor, and he said, Dr. Roy told him, I don't agree with what you're doing, but I like how you're doing it. So feel free to disagree once in a while with your advisor. It's a good way to make some progress. All right, so I want to start talking about a quarter century of Indian Precambrian paleomagnetism, and that's not to deny the fact that Indian paleomagnetism has a long history. In fact, when you look back, the very first paleomagnetic studies were in the late 1940s and 1950s. And if you look, there's a Nature article from 1958 looking at paleomagnetism of the Raj Mahal traps with Radhakrishnamurti and Sahasrabudhi. So following that, the first paleomagnetic paper that I'm aware of by all Indian authors was on Precambrian strata, Precambrian of some Indian rocks by Athabali Radhakrishnamurti. And so these papers, believe it or not, the data in some of these papers, especially the paleomagnetism of Indian rocks, which contains some Precambrian data, still pretty good. They didn't have all the techniques that we use today, but the data still resemble much what we saw when we went and reinvestigated those. So there's a good history of that. Now, I understand that a lot of people aren't necessarily familiar with paleomagnetism, so I'm going to try to give you a quick, easy description of what paleomagnetism is. It's based on the fact that rocks remember where they were born. They have magnetic minerals in them, and those magnetic minerals record where they were born. They also contain radioactive minerals, and those radioactive minerals tell us when they were born. So if we inquire from a rock sample to tell us where and when were you born, we can get that information from the rocks. Then we use that information to produce paleogeographic maps. And the way we do that is also simple. Dr. Pandit, a friend of mine in Norway, and myself, we were all born at the same time. So if you ask us what year we were born, we would give you the same answer. But if you asked us where we were born, we would get an answer of India, Norway, and the US. And so our directions would all be different, right? They wouldn't agree with one another. But Dr. Pandit and I came here by train last night from Jaipur to Udaipur. And if you followed us from the beginning of that train ride to the end of that train ride, you would see that we were traveling together. We would have the same path. We would start at the same time. We would end at the same time. We would follow the same path. So this is what we're doing when we look at Precambrian paleomagnetic data. We're trying to see where the rocks were located, and we're trying to establish whether there were fellow travelers, that some of those rocks and some of those areas were traveling together. And if we find that they were traveling together, then we can make paleogeographic maps connecting the continents. So what I'm going to go through today, I'll try to get through all of this, but I know everyone's hungry for lunch, so I may skip a little bit. But I'm going to talk about the Precambrian assembly of peninsular India, the closure of the Vindhyan Basin, which turns out to be relatively controversial, perhaps a subject that is a little more complicated, the rotation of the Dharwar Craton, and then talk about India in Colombia and Rodinia, and then look at India and the fellow traveler of South China in the late Precambrian Archean. All right, so how do we use paleomagnetic data, and how do we know when it's good? And it's really based on a few things. It's based on laboratory techniques, statistical analysis, and some idea of reliability that the magnets, that memory that those rocks have, wasn't erased by some younger event. So we grade them on 0 to 7. 0 is the worst, 7 is the best. And you can see that over time, the pre-2000, the average grade was about 3. And since 2000, the average grade has improved to about 3.5. So we're getting better, and a lot of the work is being done by research labs in India, which is incredible. They're doing great work on both geochronology and paleomagnetism. So a lot of the data I'm going to show you is from Indian researchers as well as my group. So when we look, this slide is not that informative, other than to show you in the last 25 years, these are the number of paleomagnetic poles where we feel we have a good idea of where India was located during the Precambrian. And you can see that they range in age from about 2.7 billion years ago down to about 540 million years ago. If we just kind of look at a map of, happens to be a map of every single location where samples were taken from India in the Precambrian, and you can see it's scattered mostly through the cratons, the Darwar, the Bostar, the Shingbum, the Bundelkhand, and the Aravalli, and then over in the western part of India in the Malani and Marwar regions. And dikes are typically assigned on the basis of ages, which is the best, or trends and geochemistry. If we look at the number of ages, you can see that the number of ages are far fewer. So we have to try to connect based on this directional data, trends of dikes, or other information. So again, these are only to inform you of how many paleomagnetic studies we've done versus the number of ages that we have from those paleomagnetic studies. All right, so the question, when was peninsular India assembled? Of course, I mentioned that there are 5 main cratonic nuclei, the Darwar craton, the Bostar, the Shingbum. We call these the southern Indian blocks, and in the north, we have the northern Indian blocks, the Bundelkhand and the Aravalli region, which Dr. Roy just presented a summary with. And so we want to know, were these long-lived partners? Was India always assembled, or was India assembled piecemeal throughout the Proterozoic? So what do we need? We need rocks of similar ages, and we need paleomagnetic directions from those rocks. So when was it assembled? Well, it depends on who you ask. Paleomagnetism can potentially answer this question by looking at a series of coeval rocks that have a good memory. Unfortunately, despite the progress we've made, there are still gaps in our knowledge. And so if you press me on an answer, when was peninsular India assembled? If you press me, I would say it was completed along the central Indian tectonic zone, probably wrapping around some of the deformation in the Delhi Fold Belt is also of a similar age of the deformation in the central Indian tectonic zone, and even along the Eastern Ghats. But I would say that these cratonic nuclei were assembled somewhere around 1 billion years ago, roughly speaking. All right, so what evidence do I have for that? Well, let's start with the Darwar craton and the Bostar craton, because these are 2 cratons where we have similar age rocks and we have paleomagnetic data from those rocks. And the oldest paleomagnetic data we have from both the Bostar and the Darwar are 2.37 billion years ago. The red is the Darwar, the blue is the Bostar, and you can see that those circles overlap, and that means that the Darwar and the Bostar were together at 2.37. We can also look at younger rocks. These are 1.88 billion years, and you can see that they are traveling together. So our argument is that the Bostar and the Darwar were fellow travelers since at least 2.37 billion years ago. And any orogenesis here in this is a modern rip, the PG rip, but in the Bhopal-Patnam granulite belt, any deformation in there was relatively minor and not associated with a major assembly between those cratons. If we look at the Shingbum and we compare the Shingbum to the Darwar and Bostar, for the Darwar and Bostar, we have 2.2 billion year old dikes, and we also have them from the Shingbum craton. Here you can see that they're quite different. They overlap a little bit, but they're significantly different. So this suggests that maybe the Shingbum craton was not a part of the Darwar and Bostar. But if we actually look at it carefully, there's no difference. These reflect the same latitude. So Shingbum, Darwar, and Bostar were at the same latitude. So we can say, well, is there a way to make the Shingbum a part of this, but not necessarily in its modern day configuration? And so we can rotate the Shingbum a little bit through an Euler pole in the Mahanadi Rift, and we can see that we can get those overlap 2.25. And so here we see this is probably the 2.25 configuration of Darwar, Bostar, and Shingbum, with Shingbum just rotated slightly from those 2. I argue on the basis of some 1.75 billion-year-old dikes from both Shingbum and Darwar Craton, that they were probably pretty much assembled in a quasi-rigid fashion by 1.8 billion years or slightly younger. So we have the southern India blocks all formed together by about 1.8, youngest maybe 1.75. Well, what about the northern India blocks? Well, this is where it gets a little more problematic. And the problem is simply this. We do not have rocks from the Bundelkhand Craton or from the Aravalli region that are of the same age as the rocks that we see in the Darwar, Bastar, and Shingbum. That may be due to a couple of reasons. One, they could be gone, they could be eroded. The other one could be that maybe they evolved different times. Maybe the Bundelkhand and Aravalli have different geologic histories than the Darwar, Bastar, and Shingbum. And if so, there's no reason that they should have the same age dikes and the same age orogenic events. What we do know is that there is this large central Indian tectonic zone that runs through between the Shingbum and the Bundelkhand Craton and then wraps around. And major orogenesis takes place in that region in the billion-year range. There are some older ages as well, but this one seems to be a key. And in fact, when we look at about a billion-year-old rocks from the Darwar Craton and the Bundelkhand Craton, we start to see this agreement. So I would argue, that's why I argue, if pressed, when we first recognized that Darwar, Bastar, Shingbum, and Bundelkhand were traveling together is about 1 billion years ago. So that's my argument for why that happens. And I also believe that orogenesis closed any remaining interior basins, including the upper Vindian Basin. And of course, there are people in the audience who disagree with this. I realize that. That's fine. But my argument is only the Marwar Basin contains Ediacaran age sedimentary rocks in a major basin in India. If we look at the Vindian, there's some interesting controversies about the age of the Vindian, particularly the upper Vindian. And this has led to some really unusual discoveries. And the most unusual of these that was announced in the New York Times was a natural work of art maybe hiding among Indian cave masterpieces in an overlooked fossil. And this was a big find. I remember this was during the COVID years. And it was reported that the fossil Dickinsonia was found in the Bandar sandstone. And if that's true, Dickinsonia means that those rocks are Ediacaran and that my idea is completely off the wall, completely wrong. Due to COVID, we weren't able to get back there until 2022. And this is the original fossil. And this is what we saw left of it in 2022. And it was hard for me to imagine how a fossil that lasted 550 million years or so suddenly disappeared in 3 years between 2019 and 2022. And in fact, when we took the picture of the original paper and blew it up, we saw these strange honeycomb structures that look very much like multiple bees' nests in the Bhimbetka area. And in fact, Dickinsonia was just a beehive. It was nothing more. So be careful. Sometimes you see only what you want to see, and you don't think about other possibilities. All right, so where are we in this debate about the Vindian? Well, here are the strongest constraints on upper Vindian basin sedimentary history. The Kaimur sequence is intruded by a 1073 million-year-old Majguan kimberlite. So the Kaimur must be older than that kimberlite. We have some newly dated, unpublished ages on pyroclastic deposits in the Rewa Shale that are about 1046. There are no detrital zircons in the upper Vindian, or very few, younger than about 1 billion years. That could mean that there are no source rocks for younger, or that the basin was closed by that. But more importantly, we see congruence of paleomagnetic data from Majguan, Mahoba Dike, Kaimur, Bandar, Rewa data, and a lack of congruence with paleomagnetic data from the Marwar supergroup. And then the Stenian-Tonian age orogenic events in the central Indian tectonic zone suggest final amalgamation and closure of the Vindian Basin. So I'm not going to go through these because lunch is coming, but here we can see the detrital zircon spectra. These are 1,100 detrital zircons. There's just been added another 1,200. This holds, this wall at about 1 billion years holds. Doesn't seem to be anything younger. When we look at the paleomagnetic data, this is for the Kaimur, about 1.2. This is the Great Dyke of Mahoba at 1.1. The Majgoan kimberlite at 1.07, and then the Rewa upper bander and lower bander right here between 1.05 and 0.9 billion years. All right. I'm going to go through this one quickly because this is an interesting concept that has been proposed by Soderlund and a number of his Indian colleagues. And they looked at the Darwar craton and they noticed that the close-pet batholith here runs north-south and then turns a little bit towards the northwest here. They also noted that the Chitradurga fault did the same thing. And there is a very long Andhra Karnataka long dike that extends from the southern part of the Darwar craton to the northern part. And they all have this bend, this slight bend. And the argument was, well, is this a feature that was originally present, or was the Darwar craton deformed sometime after 2.5 billion years? And it just so happens that paleomagnetism is really good at solving these problems, because when rocks record where they were and then you bend them, they're going to show that bend. And so we can evaluate whether or not there is a 30-degree rotation, so north-south, and then it bends by about 30 degrees. Paleomagnetic data can show that. And here's what they show. So what we should see is, let's just, for example, if the declination, the magnetic directions down here point this way, as they bend, they should bend and point this way. And up here, we should find the same age rocks with their arrows pointing in a different direction. So this, from the magnetic signal, we should see this rotation. Well, we looked at a bunch of rocks from 2.367 all the way down to 1.88, and we evaluated whether or not they were bent by 30 degrees in a clockwise fashion. And what you can see is that most all of these show degrees of rotation that are smaller than the errors associated with them. Except for one shows about an 18 plus or minus 5.5 degrees at 2.082. But there is no systematic difference such as we would expect. And so we argue, along with a lot of other scientists, it's very hard to deform a craton once it's lost a lot of its volatiles and radioactive elements. It becomes a very, very strong lithosphere, very, very hard to deform. And so probably those structures were just inherited from the earlier Western Darwar, Eastern Darwar collision at 2.5. So India and the Proterozoic supercontinents of Colombia and Rodinia. Colombia's supercontinent formed over an extended period of time, but somewhere between 1.78 and 1.45, it reached its maximum packing, or all the cratons were at their closest. Unfortunately, there are limited data from India at either end of that spectrum. We have a paleomagnetic pole from the Bostar at 1.46 and from the Shingbum craton at 1.76. And so we can try to take a look at that. And we can also look at Rodinia, which reached maximum packing at about 1 billion, and rifting commenced sometime prior to 0.8. So you can see these are the studies associated with that 1.7 and 1.46. And when we put those data into a global context at 1750, we can put the southern India blocks somewhere down here, close to North China, North Australia, Siberia, perhaps West Africa, and the northern India blocks sandwiched in there. That's really the best we can do. It turns out we can also flip this over and put them somewhere over here near Amazonian Fennoscandia, because we don't know the exact polarity of the magnetic field, but this is one possibility. Going forward to 1.46, we can see here, we can put the southern Indian blocks at 1.46. We can put them next to Amazonia, or we can use the opposite polarity. And again, they're close to North China, Australia, and Siberia. That's about all we can say about India right now in the Columbia supercontinent. We need more data. That's always a good problem to have. And I think, so I don't want to run over time. So I'm going to show you this really quickly, because this is an interesting illustration of how paleomagnetic data between two continents can be used. And this has to do with the connection between India and South China in the Neoproterozoic, about 800 to 720 million years ago. And during this time period, it appears, at least from a global data set, that rather than plate tectonics, which was occurring very slowly, but also the entire outer surface of the Earth. That means the mantle plus the crust and lithosphere were moving in unison due to mass imbalances in the mantle in something we call true polar wander. And true polar wander can be triggered by putting something dense, like oceanic slabs, into the upper mantle at mid-latitudes. And if you put that excess mass, the Earth wants to spin, wants to stay upright. And if you put that mass in the upper mantle, the outer surface of the Earth has to rotate about the outer core and put that mass on the equator to keep its balance. The same can happen if you have a plume coming up from the lower mantle. That plume is also going to create a mass imbalance, and the Earth is going to try to shift all that mass to the equator. And as the slab descends down through the transition zone, the opposite sense of motion will occur. So in true polar wander, what we should see is all the continents moving in unison in one direction, and then all the continents moving in unison in the other direction. And it happens over a relatively short amount of time compared to plate tectonics. True polar wander is 20 to 66 centimeters per year. Normal plate motion is somewhere between 2 and 5 centimeters per year. All right. So as an illustration, using a bus instead of a train, suppose I have two continents. We know they started at 750, we know they ended at 820, and we know they traveled 10 kilometers distance. We can calculate the rate at 20 kilometers per hour. But suppose we want to know, well, did they ever travel faster? Well, we need data between 750 and 820. And suppose we only have data from the red that they actually went this path. The blue didn't record it, but the red did. Now we can see it actually traveled at twice the rate, 40 kilometers per hour, because we have more data. And this is what we need. We need more data to evaluate true polar wander. So for India, we have data from Harohali alkaline dikes at about 820, and we have data from the Malani igneous province at about 770. So we have two endpoints of our bus tour, and we can calculate a rate. And when we calculate a rate, we get 8.9 plus or minus 2.2 centimeters per year. That is normal plate motion. There's nothing unusual about that. Okay? So if we want to show that there's true polar wander, we need to find something, we need to find data in between here. We don't have that from India. But the interesting thing is there are data from South China at 820 and 770, very similar to India at 820 and 777. But you should notice from this picture, it appears this motion is this way, whereas for South China, the motion is that way. That doesn't look like things are moving together. It looks like they're moving opposite. But if we put South China where we think it might have been and look at the data, now we have 820 million-year-old poles from India and 770 million-year-old poles from South China, and they agree, and the direction agrees. And so we can, from this, we can posit that they were traveling together. And there's geological information to support this. It's not just paleomagnetic information. And it turns out that South China has data in between there. South China has data at 770, 779, 813, and 824. So now we can fill in the gaps. And when we fill in the gaps, like we did here, we can then calculate the rates. And when we do that, we can see we get on the order of 32.7, 22, 19. And so this looks very much like true polar wander. These are rates of motion that are compatible with true polar wander. And we can look at what happens to India and China. Remember, true polar wander should show motion in one direction, and then as the slabs penetrate the lower mantle or as the plumes transit through the upper mantle, we should see the opposite motion. So here is India and South China 820 million years ago, 813 million years ago, 799 million years ago, and then the opposite sense of motion at 770. Very similar to true polar wander. We can put all of this in a global context now, and so we can see these are the continents at 820 and at 770 million years. And the big takeaway from this is that if India and South China were part of Rodinia, which they may well have been, they had already separated from the rest of Rodinia by 820 million years. And there was probably an active margin here along Madagascar, Seychelles, northwestern India, wrapping around to South China. So this is another tool that we can use in paleomagnetism to examine bigger global pictures using data from India. So I'm going to conclude with not really conclusions, but just some success stories. And the first success story is that paleomagnetism is alive and well in India. There are growing number of research groups doing really, really good work here. It's something to be proud of. And so they're at an accelerating pace, and there are still surprises, and there's still new data to be discovered in India. And I remember when I first came here, and Dr. Mundal was with me on one of these, all the Bundelkhand dikes, most all of them trends northwest-southeast. And so the assumption is, well, they must be of the same age. But it turns out there are different northwest-southeast trending dikes in the Bundelkhand craton, including one that we just recently dated at 740 million years ago. So there's still a lot to do. There's still a lot of excitement in Indian paleomagnetism and trying to put India into a global picture. So thank you very much for your attention.
Thank you very much, Professor Meet. Now it's 1:45 nearly, and we have 15 minutes for discussion for open house on both the lectures. So I request to students, especially if they have any queries, to august audience, to invited speakers, that there are two eminent scientists on the Precambrian, Professor Meet and Professor Roy are here. If any queries are there, then please ask. Mike, any questions, any queries? Yes, please. Prasanjit Ghosh from IISc.
This is first of all for first lecture from Professor Roy. He showed some beautiful slides of paleosols. So now, what is the age of those paleosols? Is there any record or any suggestion?
There are not much of elements which preserves the age of its formation. Some studies have been done. Some zircon has been available from this paleosol. And those zircons were dated, and they found to be that age, this Archaean Proterozoic boundary.
Thank you. And
I think Professor Pandit can highlight on this. Yeah, please add on it.
Yes. So I'm just adding to what Professor Roy has mentioned, that these paleosols are between the Archeans and Proterozoic. So we have a rough idea, but it's very difficult to actually pinpoint the age. But we found some ferriprites. so which indicate oxidation. And probably this could be related to something of the great oxidation event around 2200, 2300, but it's very speculative.
So to add on to this, actually now in situ rubidium strontium has been proved one of the easiest way to date clays. And
pretty close. We can go to
tomorrow
and get some samples.
I have a question for 820 million years record for India and with South China. So now that places us right in the polar region. So what are the sedimentary evidence or metasedimentary evidence we have to be consistent with that argument that about replacing it with a new dimension?
Yeah, so from India, there's nothing that I know of. These are both from igneous rock studies. And from South China, I don't know that there's anything that shows glacial, which if that's maybe what you might expect. The weird thing about the Precambrian, among other things, is that there are seeming records of things like dolomites and limestones forming at high latitudes and glacial deposits at the equator. So those typical markers that we see in the Phanerozoic become a little more problematic in trying to determine latitudinal distributions.
Any other one? Mike? Madam Kaur? Mandal sir? So, students, if any question?
Question is for Roy sir. You have mentioned for Deloitte at one slide. You have mentioned for glacial boulder beds. Glacial boulder beds.
You show in one slide a glacial boulder bed around Jaipur.
Yeah, glacier boulder. Yes.
So more about that, if you can throw some light, because that is interesting to know.
First of all,
or anybody whosoever is.
Okay. We'll have to identify whether it's a glacial or not. When you have the gathering of huge boulders and smaller ones, that is possibly rolled by the glaciers. And the well-rounded bodies, there has been some erosion is there. Okay? Assorted beds cannot form by any other means other than the glacier carrying everything.
Similar things I have also seen somewhere else. That's why I have seen in Chittorgarh similar type of things.
Yep.
I have seen it in Chittorgarh also. Chittorgarh.
Also like that.
That's what something
Glacial
interesting.
means the temperature. It should be ice covered area. It should be ice covered area. The glaciation took place from the beginning of the earth to the even today. You have the glaciation. In the Indian perspective, glaciation you get on the Himalayas. But glaciation means temperature. There is a drop. There must be a drop in temperature, so that water can form ice. Okay. Unfortunately, it is only the earth where they have water, ice, and gaseous in the atmosphere.
Madam, please, mic ले लीजिए.
Is it okay? आना ये बात सकते हैं.
Okay. Sukanta sir, Sukanta sir, please, mic.
Okay. Okay. So yes. So you were telling that Vindhyan and the Delhi, they were their age is overlapping. Yeah. But why Vindhyan is not deformed, whereas the Delhi is deformed?
Deformation depends on the tectonism taking place. You will not have the push to form the mountains. That type of. Or you can have a pool, then you have formation of lakes, rivers, and other things.
My question is that they are spatially close, but why this difference in deformation? They are close. Present day, geographically, they are
It's okay. Glacier, we're talking about the glaciation. There is one thing is the temperature. That water is changing into ice. Vindian group. Vindian is the undeformed, planar. There is no deformation.
That's what he is asking, why there is no deformation.
Post-Proterozoic sediments. Keratization is a process of solid rocks and cutwork. This is keratization. Rather, subsequently, whatever happens is term I forgot. Post-keratization period. Any other question? Yes.
Yeah.
I think, yeah.
Vishwal sir, please.
See, it is not close or far away is not the problem. The tectonic setting, what is said, one is a platform, which is deposited over a granitic basement. Another is a basin, which is over an ocean floor. So ocean floor closes by subduction, deformation, metamorphism, all these things goes there. But granitic basement basins, pericratonic basins, does not suffer from such subduction events. That's why it remains like you came from Calcutta. You came by train, it is a mobile belt, Your missus stayed in the platform. See, that's the difference. That's all. It's unfortunate. The time didn't come to. He's unfortunate. Yeah. So one more thing, sir, I just ask you. It's excellent talk. So can you just tell me your true polar wonder and the Milankovitch cycle polar wonder, are they related? Milankovitch. During Milankovitch also pole wonders.
So, yeah, so, well, they're way different time scales, right? So true polar wander is occurring over millions of years of time scale, whereas most of the Milankovitch cycles are shorter. And we do not have Milankovitch specific information from rocks during that time period to even be able to begin to answer that question. So it's a very difficult question to answer.
Okay. Fine, thank you.
Yeah.
Any other questions? Tani sir, quick question. So now it's almost 2 o'clock. Let's proceed for lunch. And then we will come by 2:45 because 3 o'clock onwards, we have got 3 keynote speakers. And out of 3, 2 are from outside India. One is from UK, Professor Graham Shields. Another is from China, Dr. Dominic Pepenu. And we have to correlate with timings with those 2 people. So I have given them time of 3 o'clock Indian Standard Time. So please be on time, especially students who are generally late. Please do come at time at 2:45. Thank you.
With this,
Yes.
With this, we conclude our inaugural function of ICEAP 2024. Thank you everyone for your active participation.